Find the area of the region bounded by the curves y is equal to x square minus 2x and y is equal to minus x square plus 4. So this is a simple question under the integral calculus where we will be identifying the area of the bounded region. So it's very simple. The first work which we are going to do is solve the two given equations. They both are parabola equations. Okay, we are going to solve the two equations and identify the values of x and y. Okay, that is the solution for these two equations. Let's first identify. We are given y is equal to x square minus 2x and y is equal to minus x square plus 4. So it is clearly understood that x square minus 2x and minus x square plus 4 are both equal. So we can equate because both are actually equal to y. This expression is also equal to y. This expression is also equal to y. So it is clearly understood that the right hand sides are also equal. So that's why we have equated. Let's solve this and identify the value of x. Let's do transposing. Let's take all the like terms one side. So minus x square comes to this side as plus x square. X square plus x square will be 2x square minus 2x. Plus 4 comes to this side as minus 4, which is equal to 0. So the entire equation we are having it as multiples of 2. Okay, the coefficients and the constant are multiples of 2. So let's divide the entire equation by 2. This becomes x square minus x minus 2 equal to 0. Now let's factorize this equation to identify the value of x. So this is minus 2 and the coefficient is minus 1. So the product of two numbers which gives minus 2 and the sum of two numbers which gives minus 1 will be 1 into 2, 1 into minus 2. 1 into minus 2 is minus 2. 1 plus of minus 2 is minus 1. So the factors will be x plus 1 and x minus 2 equal to 0. From this it is understood that x plus 1 equal to 0 implies x is equal to minus 1, then x minus 2 equal to 0, which implies x is equal to 2. So x is equal to minus 1 and x is equal to 2 are the solutions of x. Now let's identify the solution for y. That is, substitute x is equal to minus 1 in any one of these two equations. Let's consider the first equation. Y is equal to x square minus 2x. If x is equal to minus 1, okay, what happens to y? Y will be minus 1 the whole square minus 2 into minus 1. That is 1 minus 2 into minus 1 will be plus 2. So y is equal to 3. When y is equal to 3 actually? When x is equal to minus 1. So this is a solution. Now if x is equal to 2, the other solution we are taking, y will be 2 square minus 2 into 2. That is 4 minus 4, which is 0. That is y is equal to 0. When y is equal to 0? When x is equal to 2. So the solution for these two equations, that is these two curves actually, they meet at the coordinates minus 1 comma 3 and 2 comma 0. This one we have identified. So minus 1 comma 3 is a coordinate where the two curves meet and 2 comma 0 is the next coordinate where the two curves are going to meet. Now let's just draw a rough sketch of these two parabolas and identify the region for which we are going to identify the area. Okay. Okay, now let's just give values for x for this equation minus 1, 0, 1. For this equation, let's give the value for x for some minus 1, 0, 1. Okay, now for these three values of x, let's identify the corresponding values of y. Same way here also. Now, if x is going to be minus 1, just now we identified if x is going to be minus 1, in this equation, y value is equal to 3. So, this is 3. If we substitute x as 0, y value will also be 0. If we substitute x as 1, this is 1 square. So, if x is equal to 1, y will be 1 square minus 2 into 1. That is 1 minus 2, which is minus 1. So this is minus 1. So let's take these values to make the graph y is equal to x square minus 2x. Now here, we are going to substitute x as minus 1 in this equation. If we substitute x as minus 1, if x is equal to minus 1, what happens here? Y will be minus 1 square. See, the minus sign, it's already there in the question. Okay, so minus of minus 1 square plus 4. So this is going to be minus 1 the whole square will be 1 plus 4. So this will be just 3. So y is equal to 3. Right? Now here, this is going to be 0. When we substitute 0 here, y is equal to 4. When we substitute y is equal to 1, the same process will continue. Minus 1 plus 4, which is again 3. So the coordinates for this graph will be minus 1 comma 3, 0 comma 4, 1 comma 3. If we plot it, we will be getting a rough graph for the parabola y is equal to minus x square plus 4. Let's just plot it and come back to the solution. So for this graph, we are going to plot the points minus 1 comma 3, 0 comma 0 and 1 comma minus 1. For this graph, we are going to plot minus 1 comma 3, 0 comma 4, 1 comma 3. Okay. Let's plot the points of both the parabolas in this rough graph. Okay. The first point we are going to plot for the graph y is equal to x square minus 2x. Minus 1 comma 3 we are going to plot. So minus 1 comma 3. So this point. Next it's 0 comma 0. Next it's going to be 1 comma minus 1. This point. Okay. Now next for the graph y is equal to minus x square plus 4. The first point which we are going to plot is minus 1 comma 3. So minus 1 comma 3 which is already plotted. 0 comma 4. So 0 comma 4 it's here. The other point it is 1 comma 3. So 1 comma 3 it's here. Right? Now let's join to make it a graph. So can you look at this parabola? So this is going to be for the curve y is equal to minus x square plus 4. And this parabola is for the curve y is equal to x square minus 2x. Now this is the region where the two curves are binding. Okay, so we are going to identify the area of this bounded region. Okay, so from where to where, that's going to be our point. Can you see from this point in the x coordinate minus 1 to this point 2, the curve is bounded by the two curves. So from minus 1 to 2, okay, we are going to identify the area of these two curves, that is the area of the region bounded by these two curves. Okay, so let's do it. First we'll take the curve at the top minus the curve at the bottom. So this curve minus this curve. We are going to integrate it with respect to x because the limits which we have considered are from the x-axis. Suppose if you consider the limits from the y-axis, then you will be having to differentiate it with respect to y. However, the equations are having x as the dependent variable. So it is better choice and it is the best choice to choose to integrate it with respect to x, having the x limits. Okay, so let's start. Right? So the curve in the top minus the curve in the bottom, we are integrating with respect to x because we have considered the x limits. Okay, so from this point minus 1 to this point, can you see children in the x-axis from here, okay, till here? That's why minus 1 to 2. That is how we are choosing the limits actually. Okay, now let's integrate it. So this is minus x square. First let's simplify and then integrate. So this is integral minus 1 to 2 minus x square plus 4. Take the negative sign inside, it goes as minus x square plus 2x dx. Nothing is possible to cancel. So let's simplify. Minus 1 to 2. Minus x square becomes minus 2x square plus 2x plus 4 dx. Let's integrate it now. Minus 2, have it as it is. X square, if you integrate, that's going to be x cube by 3. 2x, if you integrate, that will be x square by 2. 4, if we integrate, that's going to be 4x. Between the integral limits, minus 1 to 2. Let's substitute it. Upper limit 2 we are going to substitute. So this is minus 2 into 2 cube by 3 plus 2 into 2 square by 2 plus 4 into 2. This is for the upper limit minus. Substitute the lower limit now. It is minus 1. So minus 2 into minus 1 the whole cube by 3 plus 2 into minus 1 the whole square by 2 plus 4 into minus 1. So this becomes minus 2 into 8 by 3. 2 and 2 gets cancelled. This is plus 4 plus 8 minus 2 into minus 1 by 3. 2 and 2 gets cancelled. This is plus 1 minus 4. Again, this can be simplified. This is 2 into 8, 16. Minus 16 by 3 plus 8 plus 4 is 12. Minus into minus becomes plus. So this is 2 by 3 minus 3. Let's take the negative sign inside. This is minus 16 by 3 plus 12 minus 2 by 3. Minus of minus 3 is plus 3. Right. Now 12 plus 3 becomes 15. So here minus 16 minus 2 by 3. Because the two fractions are having the same denominator like fractions, so we can club it like this, plus 15. Minus 16 minus 2 becomes minus 18 by 3 plus 15. Minus 18 by 3, that is minus 6 plus 15, which is 9. So this will be 9 unit squares, which is nothing but the area of this bounded region. Okay, hope you all understood. Thank you.